All right, welcome back. Continuing from where we left off, or almost continuing. I should say that I did go ahead and sort everything in the Palm. So now my plugins are alphabetically ordered, and I committed that. So those are the changes that I've made since then. But coming back to where we left off, we added some logging. We had a default logging output. Let's go ahead and configure what our logging looks like. So we're using logback. So if I just Google logback.xml, that's the name of the logback configuration file. Let's find some XML example configuration. So this is Java and Java, some example output. Okay, so here's some example configuration XML. Let me copy that. Scrolling down a little further, see if there's anything else. So that looks like basically the same thing, or nearly the same thing. Anything else useful in here? Okay, so this one's a little bit more useful because it actually includes a logger. So let's go ahead and copy this one instead. All right, copy. So we need a place to put our logback.xml file, and it needs to be on the class path so that our jar classes can access it as a resource. So what I'm going to do is I'm going to create a new directory, and I'm going to use one of these Maven directories. So in this case, inside the tutorial API server, right, the server is basically going to be running everything. So I'm going to put the logging configuration in here, and I'll say that this logging configuration is only going to be used when running locally. When we actually deploy this to a server, we're going to have a separate file on the file system somewhere, not bundled in the jar. So that way, if we need to modify it, then we can go ahead and modify it, on disk easily without having to crack open one of these jars and mess with it. So, yeah, this logback that we're about to create is only going to be used when running locally. So I'll go ahead and create this source main resources directory. This is a special Maven directory. Maven will automatically put things in this directory onto our class path for us. So that's the good thing about following Maven's conventions. Logback.xml, and then I'm going to paste in and then format this snippet from this website. So top and bottom is configuration, so all the logback configuration information fits within that XML fragment. Still messing with XML. Our next thing is an appender. So appenders determine what happens with the logging output. So in this case, we have a console appender, which is just going to write it to our console output, our terminal, which is fine since we're only going to be using this logging configuration when running locally anyway. When we deploy this stuff to a server, we'll use a file appender, so that way our logging output goes to a log file. Within this appender, we have, delete that comment, we have this encoder. This encoder indicates the pattern to use when writing log messages. If I run this server again, we saw from last time, so here's, it's actually already using our new configuration. So this configuration is slightly different than last time, right? Because we have a little bit truncated logger here, because it used to say com.tutorialapi.server. Now it's just c.t. So it is slightly different. And also there's an extra space in here. So this format is different than the default format, which makes sense. And we're going to change it even more. So right now it's just printing out timestamp information from the date. I'd like to see the whole date, so I'm going to delete all the stuff in those curly braces. It's also showing a thread in square brackets. I don't really care about the thread. Like if we were doing multi-threaded things, I would care a lot more about the thread. But Jetty's going to be managing all of our threads for us, or I should say most of our threads for us. So we won't worry about that for now, especially when doing local development. On a server, we might add that thread information back in case we need to do some debugging on the server itself, but we can worry about that later. The level here, and it has this -5 in the definition. So the 5 here means it should take up 5 spaces, and the minus means it should be left aligned. So that's what added this extra space after the info and the output. And they chose 5 here because the levels are sometimes 5 characters, right? Like error is a 5-letter word, debug, info is only 4. What are the other ones? Warn is only 4. So basically, they're 4 or 5 characters. And so by specifying -5, that makes this column width consistent. And so the 4-letter word levels will end up with an extra space after them. Logger is similar here. They did add this 36 at the end in braces that basically says allow that logger to be at most 36 characters wide. And in this case, because this whole class name, including package, is longer than 36, it truncated com to just C, and then it truncated tutorial API to just T. So if I make this bigger, a larger number, then it would add those back in as long as I had enough space for it. We can do something similar with kind of like the -5 for the level. We can do minus, say, like 50, and then make this 50. That way, this column will always be 50 characters wide, and it'll left align it and add padding at the end. You can also do %L. I think %L is the line number, and we'll see in a second. And if it's not, then I'll Google it out. Then we'll do a dash in the message. So this format probably will work pretty well for local testing. For loggers, each logger specifies configuration for, or it allows you to specify the specific level for the class that you're logging to. Or I shouldn't call it class, even though it's normally a class. It's the logger name. So in this case, we're using the class here, but we could use something else, right? Like we could just put server in here, and then my logging output, this whole thing here wouldn't be the class name, potentially truncated a little bit. It would just be the word server. And since I modified the configuration to be 50 characters wide, it would be server with a bunch of space after it. And we'll take advantage of these kinds of loggers later on, but for now I'm just going to put the class back in here. And that's normal. It's normal to use the class when you're logging. And then it's also normal when you're defining loggers, which I'll put this at the bottom, to put the beginning part of the package in here. So I'm going to do com.tutorial API, and I'll have all the tutorial API logging at info level. And I'll also set the root level to info. And we'll pretty much leave this log file like this. I guess I can get rid of this blank line too. So what root means anything that you don't have specific loggers defined for will log at this root level. So pretty much everything's going to be at info level. And we'll tweak this here in a second or later. We'll add more loggers for things that we don't want to see, or if we want to do some extra debugging and see debug logs, then we'll come in here and tweak these levels from info to debug or whatever. Also at the root level, we tell it what appender we want to write to. So everything is going to go to this standard out appender here. And when we write our server, our real logback.xml, when we deploy to a server, we'll tweak this a lot. We'll have file appenders, and we'll have the file appender, the files roll over, once, probably every day, and then we'll only keep a certain number of them because we don't want the log files piling up and filling the disk and things like that. So we'll make this more complicated, but we're not going to do that for now. For now, this file is really just used for when we run the server locally, so that we can see, debug information basically when we run. So now that I've modified everything, let's go ahead and run this again and see how our output changed. Okay. So we've got, we've got our full date this time, which is we get from our %d. We've got our 5-character level. We've got our 50-character class, which It looks okay down here. I don't like this 13 way off to the side though, so what I'm going to do is move this L to the front, and I'll say let's make it most line numbers are going to be 3 digits or less, so I'll just say -3. If we have a case where it's 4, then yeah, it'll mess up the columns a little bit, but I don't expect that to happen too frequently. I'll go ahead and restart this. Okay, so now we've got our line number at the front, and then this colon still looks a little bit weird. Maybe I should make it 4, and just put a space in there. We'll run it last time. Kind of nitpicking a little bit here. Doesn't none of this matters too much, but I think this is fine. We'll just leave it at this. All right, so that's our logback configuration. Let's go ahead and git add everything and verify what we're adding. Okay, so we've got just our new logback file. And we'll push that on up. Okay. So, all right, we're done with login for now. Let's come back to the Jetty stuff. Now, I mentioned HTTPS here. We do want our server to run in secure mode with all comms coming into it, protected with TLS encryption over HTTPS. So in order to do that, we need some certificates to use locally. Now once we get to our server, we're going to use Let's Encrypt, which is I'll just Google that real quick. You can Google this up and research what it is, but it's a free automated certificate authority that you can generate TLS certificates for, and kind of automatically install them on your server and things like that. So once we're running at Amazon, we're going to use this for our certificates. So they're going to be real certificates, signed, trusted, and verifiable and everything like that. So we're not going to get any encryption warnings or anything like that once we're running in production. For now, though, just to run locally and do testing locally, still over HTTPS, let's go ahead and create our own configuration for certificates. So we'll create our own certificates. They'll be self-signed, which is okay just when running locally, but it's not something that we would use on a production server, but it's something that we'll need to do just for locally. So I'll go ahead and create a new directory inside our resources. Well, I guess the question is, should it be up here, or maybe I should put it at the top level? I'll put it in here for now, and we might decide to change it or move it later. So I'm going to create a new bash shell script called generate certs.sh. Now, if you're running under Windows, you could do this with a DOS command script or a PowerShell script or whatever. I haven't done any of that in a really long time, so I don't know what that process would look like kind of off the top of my head, but I'm going to use OpenSSL commands. So I'm pretty sure there's an OpenSSL for Windows that you can use to do this same thing. You could probably use the Java key tool utility to do this as well, but it takes some Googling that stuff out to find out exactly what it is. But for Mac people like myself and Linux people, this should work the same in either environment. And so yeah, we'll go ahead and start typing out this shell script. So bin shell, the first thing we're going to do is cd into this directory just to make sure that the files get created inside this certs directory. This is an imperfect way of doing that, but I'm going to ignore those details for now. Like, this script is only going to be run a few number of times locally in our environment just to generate test certificates. We'll commit them into GitHub, so we don't have to generate them every time or anything like that. Just kind of a run once or twice sort of script. So this isn't necessarily the perfect way of doing this, but it's good enough for what we're trying to do. All right, so we're going to have basically two sections in this in this script, we're going to create a fake certificate authority certificate and key. And then we're going to use that certificate authority to sign a self-signed certificate for our server. So create, I'll call it the server certificate and key. So these are going to be our two main sections. For the CA certificate, let's go ahead and create the private key. We use OpenSSL gen RSA. So we're going to generate an RSA type symmetric key. So RSA has a public key and a private key. So in this case, we're going to call it ca.priv. Priv stands for private key. And we're going to have it 2048 bits long. So you could make it for 4096 or about 2048 is fine. 2048 I think is more normal, more common. All right, so let's kind of run this at the same time. I'll just do bash tutorial API server, source menu resources, certs, gen. Okay, so I'll kind of run this back and forth as we're typing this out just to make sure the commands are working. So this command ran successfully. It generated an RSA key. It picked up our size, no problem. Did some randomization stuff, which I don't care about too much. But now I have a ca.priv, and it had this file. When I open it up, has an RSA private key inside it. Okay, so that first step looks pretty good. The next thing we're going to do is create a certificate using that private key. So let's do OpenSSL request, a certificate request. The certificate format is going to be a 509, X509 certificate. We want a new one. We want no des. It looks like nodes, but it's no des. Des is encryption. So we're not going to encrypt this file at all. We're going to use the SHA-256 hash function. By the way, if I'm saying words or phrases that don't make sense, if you care, you can Google them out. It doesn't really matter that much. You can basically just type what I'm typing, and it'll work out in the end. We need to specify how many days our certificate is going to be valid for. So, not to 365. We'll make it for a year. You can go longer. It doesn't matter that much. We'll do 1825. We'll go ahead and say what our key is, and that's the file we just generated, the ca.priv up here. And then we need to specify the output file, which is going to be our CA certificate. And we need to give our CA a subject. So the subject is going to be an OpenSSL formatted distinguished name. So you've probably seen distinguished names in the past for certificates. So we can specify the country as the US. We'll give it an O or an organization. Actually, that's not given an organization. We'll just jump straight to the common name and just call it, well, yeah, we'll give it an organization. So O equals tutorial API. And then CN, the common name is going to be CA for certificate authority. Okay, let's run this and see if everything still works. Okay, now we should have a certificate, begin certificate. Everything looks good here. All right, so the next step is to generate, so that's all we need for our CA. Let's come down and generate a private key for our server. So we'll call it tutorial API.priv. We'll make it 2048 as well. Next thing we'll do is OpenSSL. We'll do a request again, -new. And we're not going to generate an X509 cert on this one. We're going to generate a certificate request, a CSR, certificate signing request, because we're not just going to create a cert. We want it to be created that's signed by our certificate authority, our fake certificate authority certs that we created above. So let's make the key tutorial API .priv, that's what we created in the previous line. Output's going to be tutorial API.csr, our certificate signing request. And then our subject will make something like C equals US, O equals tutorial API. And then CN, it will be something like tutorialapi.com. It's hard to type tutorial API. You know, we don't actually own this domain yet, but under the assumption that we'll own it in the future, we'll go ahead and call it that. And if we don't, we'll just change it. Okay, so looks like our second key was generated without a problem. And if I click over here, I see the CSR and the private key, so that part's looking good. Next step, we need to create some extension information. So I'm going to use cat to basically create a new file containing our extensions. So I'll call it tutorialapi.ext for extensions. So the syntax might not be seen normally. So basically I'm saying everything in between this EOF to this EOF, what EOF stands for end of file. I'm going to type some stuff in here, and all that stuff will be catted out to this file. So that I'm basically just going to create a file called tutorialapi.ext that has these lines in it. So I need, like, all I'm going to do is specify subject, alt, names, and then I'll do this. So this is an OpenSSL file that specifies subject alternative names inside our certificate that gives it additional host names. So I may have said a bunch of words that don't make sense, but you can Google that out. Basically, we want, when this certificate is used by somebody hitting it with a web browser, we need to accept kind of multiple domain names and have it not give us errors. So we'll say DNS1 is the local host because we're gonna, we're gonna use this cert locally, so we're gonna hit it with localhost and then a port number. So the second one we can call tutorialapi.com, and then the third one we can call www.tutorialapi.com. All right, so now that we have our extensions file, we can use OpenSSL and create our certificate. And we're going to use our tutorialapi.csr, our certificate signing request as input. We're going to give it the CA certificate as input as well, and the CA key. And we're going to create the tutorialapi.cert as output. Go ahead and put this on the next line. We want our CA to create a serial number file, so that way if we regenerate it, it can just use the next serial number. We want it, I guess we'll give it the same number of days. We want it to use the SHA-256 hash function, and we want it to use the ext file that we just created. All right, so let's run this and verify that it creates okay, so I see getting private key, signature, okay, subject, okay, so it should have created the cert, okay, I see the cert file here now. Now we have the cert, so we have cert and priv, but what I want is to put those into a key store, a PKCS12 key store, so that we can use them within our Java code for our Jetty server. So let's do OpenSSL PKCS12, which is used to create a PKCS12 formatted key store. We want to export our certificate with our key, because this key store is not only going to have the certificate, but it'll have the key in it as well. So that's the priv file. There's also a cert file. I'm not sure which one of those it used because we're specifying the certificate twice, in and for cert file. I'm not sure about that. We'll give it a password. I'll change it because it should be changed. And then we'll give it a name of tutorial API. Okay. So actually, let's go ahead and run that and make sure we get a. Okay, we got a P12, but I need to specify dash out so that it actually goes into an output file instead of printing all those bytes to the screen. So something like tutorial API.p12. Let me put this stuff on the next line. Let me try that. There we go. Okay, now we have our P12. And let's go ahead and put our, let's generate a couple files based on this P12. So let's generate a pub and a PEM formatted output as well. So OpenSSL, PKCS12, in will be our key store, which is tutorial API.p12. Out will be our pub file we'll do first, so tutorial.pub. We want the certs, and we don't want the keys since this is the public file, and we need to specify the password for our key store, which is the very secure change it. I'm going to put those on the next line. So we also want a PEM, so I'll change this pub to PEM. And this one we want the we want no des because we don't want it to be encrypted. We don't want, or we want the certs in it as well, and we still want to pass in and password. So I think that's it. Okay. All right. Let's run this again and see. All right. So we got 2 MAC verified OKs. That's reading from the P12. Okay. There we go. We got our PEM, which has these bag attributes, the cert, and then the CA certificate, and then the private key. Okay, so that's the full PEM, which is good. And then in the pub, we get the certificate plus the bag attribute, so that one looks good as well. And if we just want the certificate, then we have that in the CRT. So now we've got kind of all the different formats that we could ever need, whether we're going to use this certain key in Nginx as a web server directly, or if we're going to use the P12 in Java, which is what we're going to do next, or whatever. So now we've got everything created, and we're ready to use that key store in our server. Let's go ahead and check our status. Let's add everything. All right, so we've got all of our new generated files for our certificate authority, plus our tutorial API server, cert, plus our script that we use to generate them. I'll say add key store plus certs keys, and push it up to the server. So now if I just verify everything, do a refresh here, server, source main, resources, certs, everything here. All right, good to go. That's it for this one, and I'll see you next time. Thank you.